Hi everyone, and welcome to the next part of the e-learning where we will go through some examples for you to familiarize yourself with the formula to find the arc length. Let's take a look at example 1. Question 1 says to find the length of the minor arc. Now we know minor arc actually means the smaller one, so this is actually the part that it's referring to. And simply applying the formula, we simply use this angle over here, 150 degrees divided by 360 degrees times 2 pi r. In this case, the radius is 3 meters. Now, because the question says to take pi to be 3.142, we usually just substitute in and key this into your calculator and you will get 7.855 meters. Now, do we need to round this off to three significant figures? The answer is no, because pi is taken to be an exact number, so you leave the value as an exact value. Now, what happens when the question does not give you the pi value? All you have to do is to use the calculator pi value. Alright, all you have to do is to use the calculator pi value, and you will see this in the later examples. Let's move to example 2. Now, example 2 is a little different because now they give you the arc length and they want you to find the radius of the circle. So because the radius of the circle is an unknown, you simply let the radius of the circle be r, apply the formula again. Okay, 210 over 360 times 2 pi r equals to 25. Simplify this, key this part into your calculator. Okay, here I put ... because it's a non-exact value. Okay, you will get this equation, and to find r, I just divide 25 by this number over here to get 6.8200 centimeters. And then here, you realize that you have to change this to 3SF. Why? Because this is not an exact value, so you need to change this to 3 significant figures. Alright, okay. Let's move to example 3. You notice that in example 3 here, I actually did not give you any value of pi. This means that you have to use the calculator pi value. Let's take a look at part 1. Okay, part 1, they want us to find the length of the major arc AYB. Okay, they want me to find the length of this major arc over here. Similarly, just apply the formula 228 degrees over 360 times 2 times pi times r, which is 25. Key this into your calculator, you'll get 99.4837 and change this to 3 significant figure to get 99.5 centimeters. The second part wants us to find the perimeter of the minor sector OAXB, meaning this green color part over here. They want us to find the perimeter of this particular part over here. So in order to do that, I need to find the arc length AXB, and I need to add it together to the two radius, and that's what I'll do. Now you realize to find the length of the minor arc, I do not have to make use of this angle. I can simply find the circumference of the whole circle and take away what I have already found, which is 9.4837. Key this into your calculator, you get 57.5959. And of course, you do not change it to 3SF yet because this is not our final answer. So to find the perimeter, you add 25 twice because 25 one here, 25 twice here. Okay, simplify this and you will get 108 centimeters in 3 significant figures. Okay, the next part, example 4. Example 4 is slightly more challenging because now I require you to tap on your knowledge of other topics, and you will see what I mean in a few moments. In the figure, O is the center of the circle with a radius 8 meters. The points P and R lie on the circumference of the circle, and OPQ is a straight line. So based on this, they want us to find the length of the minor arc RP, which isn't too difficult because we know that the corresponding angle is 36.9 degrees. So the length of the minor arc is just 36.9 divided by 360 times 2 pi r, r being 8. Okay, simplify this, you'll get 5.15 meters. And then the next part, what they want us to do is to find the length of RQ. So, how do I find the length of RQ? Notice that this is a right-angled triangle over here. And if you would recall, when there's a right-angled triangle, there are two things you can do. You can either use Pythagoras theorem, or you can use Tuakaso. Alright, but in this case, you realize that you cannot use Pythagoras theorem because you do not have the length of OQ entirely. Yes, you have the length of OP because you know that this is 8 over here, but how about this remaining part PQ over here? You don't know that part. So this means that you have no choice but to use Tuakaso. So how do we do that? Which trigonometric ratio should we use? How do I find the length of RQ? Notice this is the angle of interest. This is the opposite, this is the adjacent. So the trigonometric ratio that I should use, because I have O and A, is the tangent ratio. Tangent 36.9 degrees is RQ divided by 8. Simplify this and I will get RQ equals to this value over here. Simplify this, I will get 6.01 meters to 3 SF. So I know RQ is 6.10 meters to 3 SF. And hence now they want me to find the perimeter of the shaded area. The shaded area is the red color portion. How do I do that? In order to do that, okay, first I need to find the length of PQ, because I already have this length over here and I already have this length over here. Now it remains for me to find PQ. How do I do that? You see, I already have this length over here. I know that this is 6.00656 meters. I can directly find this length over here by Pythagoras theorem. Okay, so using Pythagoras theorem, this length over here is square root of 8 square plus 6.00565 square. Now, when you substitute in, do not use the 3 significant value. Use the 5 SF value. Change this, okay, evaluate this, but do not round this off yet. And to find PQ, I take this value minus 8. Notice that OP is also 8 meters because it is the radius of the circle as well. This gives me 2.003 meters. So to find the total perimeter, add up the 3 lengths that I know, RP, which I found earlier, plus 6.005656, which I found earlier, plus PQ, which we have just found, and you will get 13.2 meters as the perimeter. Alright, so let's move on to our last example. Okay, in our last example, we are required to show that angle AOB is 115.6 degrees. Okay, the figure shows a sector of the circle with center O and a radius 13 cm. Now, if this side is 13 cm, what can you tell me about this side? Okay, try and think about it. This side will actually also be 13 cm, isn't it? Because this side will also be the radius of the big circle. Can you see this big imaginary circle over here? So, because I have this length over here, 13 cm, I have this length over here, and I have this length over here. In order to find the angle, you notice that we cannot use Dwacaso because there's no right-angled triangle. We cannot use sine rule because we do not know anything about these angles over here. So the only thing we can do when you have 3 lengths and no angles is actually to use the cosine rule. Okay, so by the cosine rule, just to quickly recap, okay, by the cosine rule, 22 square is actually equals to 13 square plus 13 square minus 2, 13 times 13, cosine of angle AOB. Okay, make cosine angle AOB the subject by doing some simple manipulation. Bring 13 square and 13 square over to get this left, okay. The 146 divided by negative 2 times 13 gives me this. Okay, and so now I can find angle AOB by simply taking the inverse of negative 73 over 169, and this gives me 115.6 degrees to 1 decimal place. Okay, so hence find the perimeter of the shaded region. Now this part is not that difficult because the shaded region over here, sorry, it's a bit faint, okay, but it's actually referring to this green portion over here. Okay, it is enclosed by AB and arc AB. So to find the perimeter, it is not hard. All I have to do is to find this arc over here, and I can simply do this by using 115.591 degrees, which I found from my angle earlier, divided by 360 degrees, times 2 pi times 13, 2 pi r. Now, where do you get this number from? You actually got this number from here, just that I didn't show it. Cosine inverse negative 73 over 169 actually will give me 115.591 degrees to 3 decimal places. So this is the angle over here, and to find the arc length, simply use the formula times 2 pi r. Okay, and of course I have to add this additional 22. This will give me 26.2267 centimeters. And to round off, I will get 26.2 centimeters to 3 SF. Okay, so I hope these 5 examples was helpful for you in understanding not just how the formula is used, but how this topic actually is quite closely related to other topics like trigonometry, like Pythagoras theorem, things that you have learned in Sec 2 before, and even things that you have learned earlier like the sine rule and cosine rule. Alright, so please make sure you finish up assignment 1. Okay, this is due on the first lesson of term 3 of week 1. Now, I noticed that in the printing, some of it is actually not very clear. So what I want you to do is to take note for question 3 and question 4. Okay, turn to your homework assignment 1, which is on the second last page. Alright, on question 3 and 4, these two parts are the shaded area. Okay, so I want you to take note of that. Alright, so I will see you in the next video where we will run through how to find the area of the sector. Alright, thank you.